Find the volume of the solid obtained by rotating the region bounded by y equals negative the quantity of x minus 4 squared plus 6 and the line y equals 2. This is going to be rotated about the line x equals 1. Let's draw the graph. We have y equals negative the quantity of x minus 4 squared plus 6. This is actually standard form for a parabola, but it's been transformed. There's been some alterations to regular y equals x squared. The minus out front shows that it's been flipped, reflected over the x-axis. The minus 4 that's in there with the x shows that it's been shifted 4 units, but not to the left, to the right. The plus 6 at the end shows it's been shifted 6 units up. So basically, this is the standard form where you have a times the quantity x minus h squared plus k. Y equals that is the parabola, and the vertex is hk. Alright, great. So then we have the line y equals 2. We want to find out where they intersect at. Set them equal to each other. Now you don't have to multiply out the x minus 4 quantity squared. It's tempting. You'd think you'd have to do that. But no, let's just subtract the 6 over and you'll have 4. If we subtract the 6 over, we'll have a negative 4, but then this guy will also be negative, so we just make everything positive. 4 should be equal to x minus 4 quantity squared. Don't multiply out. Right now, take the square root of both sides. Underneath the square root, you have the x minus 4 quantity squared, so you just get x minus 4, and either that's going to be a 2, positive, or a negative 2. If x minus 4 is 2, that means that x is 6. If x minus 4 is negative 2, that means that x is 2. Okay, great. We have all the information we need. We have a parabola with a vertex of 4, 6, opening downward. Just the sketch is good enough. We have the line y equals 2. We know where they intersect at, 2 and 6. This region between these two will be rotated about the line x equals 1. Alright, now let's figure out which method we're going to use. So let's have a drawing, the graph of each, the graph twice, and we'll try each method. The first method is where you draw a rectangle that's parallel to the axis of rotation. The second one is where you draw a rectangle that is perpendicular to the axis of rotation. If you're parallel to the axis of rotation, then that's going to be shell. If you're perpendicular to the axis of rotation, it's either disc or washer. And this one's going to be washer because of the gap between your region and your axis. With the one on the left here, we have a rectangle that's upwards, that's a upright, vertical rectangle that's going to be moved to the left. So that's going to be in x, while this washer would be in y. But there's an issue with this washer that we can automatically rule that method out. With this being the axis of rotation, we notice that if I find the outer and the inner radius, it would be both would have the parabola as the bounds, and so that's just it's not going to work out to try washer. So let's focus on shell. Formula for shell, nx, requires us to find the radius and the height. And so the radius is a line that goes from your axis up to that rectangle. When we're moved away from the y-axis like this, it must be an addition or a subtraction of two quantities. This one is one quantity subtracted from another. We have the distance that takes us to the rectangle And then we have the distance that takes us to the axis of rotation. If we subtract that distance to the rectangle, from the distance to the rectangle, if we subtract the distance to the axis, then we'll get the radius. The distance to the rectangle is the distance off of the y-axis. That's called x. Well, the distance to the axis will always be 1, and we're going to subtract 1 from the x. So the radius is x minus 1. The height of the rectangle will be the difference between the functions, the upper function minus the lower function, the parabola minus the line. So if I could write it like this, I have parabola, and I take away 2 from it. Well, just take away 2 from the 6 and make it a 4, and would have 4 minus that quantity squared. For simplification's sake, we're going to have to multiply out this time. So if we square out x minus 4 quantity squared, we get x squared minus 8x plus 16. That's subtracted, remember, from 4. So we apply the minus everywhere, and we end up combining the 4 and the negative 16. Here's what we have. Negative x squared plus the 8x minus the 12. That's going to be the height of your rectangle, your typical rectangle. So we have our radius, we have our height. We just need the limits of integration, and we're good to go. Where does this thing start at? Well, it starts on the left here at x equals 2. It's done on the right here at x equals 6. So we have the setup. 2 pi times the integral from 2 to 6. The radius of x minus 1 times the height of negative x squared plus 8x minus 12. That'll give us our volume. Now let's perform the calculation. We're going to have to multiply out x minus 1 times this quantity for the height, negative x squared plus 8x minus 12. Let's multiply that out. So let's distribute the x across. And that's just going to basically up the power on each of these guys and have negative x cubed and positive 8x squared and minus 12x. When we multiply the negative 1 across, essentially that just changed the sign of all these guys. I'm going to write this out a special kind of way though. So I'll get a positive x squared, I'll get a negative 8x, and I'll get a positive 12. I stagger it like this, writing powers that match on top of each other so I can add vertically. And I end up with negative x cubed plus 9x squared minus 20x plus 12. It's just an aid to help you to do it out the way. You don't have to. That's our integrand. We are integrating that from 2 to 6. But don't forget about the 2 pi on the outside. So it's just power rule in reverse here. Antiderivative of each one of these guys. And we get negative x to the 4th over 4 from the first guy. Now here we're going to get 9x cubed over 3. The 9 over 3 becomes a 3. Here we're going to get 20x squared over 2. The 2 over 20 becomes a 10. And then we just get 12x. Finding the antiderivative. Fundamental theorem of calculus says you're going to plug a 6 into this. Then you're going to plug a 2 into this. And you're going to subtract. I know it's tedious to write this out, but it helps when it comes time to get the answer if you write it out like this. So here's the key. You don't have a calculator. Please don't take 6 to the 4th power. Okay. And so, you should really I think you should write it as just 4 copies of 6, multiply it out. 6 cubed, go ahead and do that. That's 36 times 6. So that's 216. 6 squared is 36, so go ahead and do that one. Call that 360. And 12 times 6, go ahead and call that 72. On the other side here, this one comes out nicer without the fraction because we'll have 16 over 4. Be careful, there's a negative on that. So that's a negative 4. 3 times 8 is 24. We'll have the minus 40 and then the plus 24. So here's how this is going to work. This 4 is like a 2 times 2. Okay, this 2 would turn this guy into a 3. This 2 would turn this guy into a 3. We have 3 times 3 times 6 times 6. Another way to think about it would be, it's like having 18 squared. And 18 squared is 324. You don't have to have that memorized. If you need to multiply it out, then you multiply it out. But there's this negative. Don't forget about that negative. So we have 324. If you triple 216, think about it as like tripling to 16, and then you get 48, and then tripling 200, and you get 648. Take away the 360, add on to 72. And then look over here, we'll have basically put the positives together, get 48. Put the negatives together, take away 44. Okay, so that's a 4. Put the positives together here, and we get 648 and 72. That'll be a solid 720. And then put the negatives together here and get negative 684. So from that 720, we take away 684. That should be 36. And then from that 36, we take away 4. And that's how we end up with 32. Then we have to double that 32. It's 2 pi. It's 2 pi on the outside. Final answer is 64 pi. Whatever units you have, cubed. That'll be the volume of the shape.